So once you have a complete network diagram that shows all the logical relationship among and between all block breakdown structure tasks, the next thing is for you to do what we call a computing process. And the reason you are doing the computing process, so they can help you find out the earliest time and the latest time for each work breakdown structure test. Meaning, how soon can your work breakdown structure test start, and how soon can you identify activity need to finish. And same thing, how late can each of your work breakdown structure tasks start, how late can you finish. Because once you have the early start and early finish day and late start and late finish day, and plus with the duration you have for each work breakdown structure task, then you'll be able to figure out the project time you need after you add all the work breakdown structure task, the duration, and their early start and late finish days. You would also be able to answer the question for each work breakdown structure task. How much longer can they be delayed without affecting the what they call critical path, the longest, the project time. Any activity that being delayed on any task on the work breakdown structure on the critical path will be delayed for the entire project. So here will be the information you'll be given, and you have, just like you have work breakdown structure text, and then you have all your preceding activity. Plus, now you have the time, the duration that you need to complete each activity. And then here's a chart. So here's a template. You create a box with a description of your work breakdown structure tasks, so package. This is your identifiers. The box on your upper left corner is your early start. On the upper right corner, your early finish. How soon can you finish? How early can you start? How early can you finish? Late start, late finish on the bottom right and left. How late can you start? How late can you finish? This is the duration for each activity. This is a slack time. How long can you wait without affecting the entire project time? Slack time basically is the difference between early start and late start. So you can subtract the early start from late start, will give you a slack time. The slack time is a 0, meaning that is the task on critical path, but indicating you cannot wait. There's no way you have some slack time to wait. You have to finish it on time, otherwise your entire project will be delayed. If it's not 0, then meaning that you have more time you can wait without affecting your entire project time. So here's how you do. First, you have to do what we call forward path, and this is the way you compute. First, you want to add all the activity along each path in the networks, which will be early start plus duration will become the early finish. Once you have early finish, you want to carry over to the next activity. When you become early start of the next activity, on this, the next succeeding activity is a merge activity, in which case the largest early finish of preceding activity is selected. Let me show you what I mean by that. So here you have early start 0, because that's the start node, and then there's a duration. So 0 plus 10 will be your early finish, early start, early finish. Now you carry over your early finish to the following activity. So you put 10 as the early start of activity B and 10 for early activity C. And then 10 plus 5 will become 15. 10 plus 25 become 35, right? And continue to carry over your early finish to the following activity 35. Continue the same fashion. They will give you 85 and 50 as the early finish date for activity E and F. Now you have a merge activity, okay? And then what you try to find out is the largest the early finish date of its all preceding activity. So since you have 8550, it's very likely you can put 85 into carrying over, but you are not sure since you have not done the activity on the top. So if you continue to do the same way that you did in the bottom, then you would have early finish 15 for activity B, carry over 15 plus 20, 35 early finish. For activity D, carry over 35 plus 35 early finish 70. Now, since it's a merge activity, you have to look for the largest, the early finish date of its all preceding activity. So you have 70, 85, 50, and 85 is the winner. So put 85 as the early finish date of your final node activity edge plus 15, and that will give you the earliest finish date for your entire project. That will be the hundreds. That will be the hundreds, and that will conclude your forward path. And later you're going to do the backward path to figure out your late finish and late start and your slack time. Now let's show you the backward path. The backward path use the logic as your forward path, except they are using subtraction instead of the addition. So here are the rule, which is you want to subtract activity time along each path in the network, carry the late start to the next activity because you're going backward, and that late start becomes the last finish of your preceding activity. The next succeeding activity is a burst activity, in which case the smallest, the late finish or preceding activity selected. You're going backward, you look for the smallest numbers. So let's go backwards. Now you're doing backward. So what you have was early finish 100 day. You kind of move it because the final node. So the early finish become your late finish day. Remember, when you did forward path, you use addition. Now you're using subtraction. So 100 subtract 100 minus 15 become 85. And 85 will be carried over, become the late finish date of all its preceding activity. They become 85, 85, 85. Let's use the one on the top as example. You subtract 85, subtract 35, become 50. Right? 50 carry over, become the late finish date of its preceding activity D, and subtract 20, become 30. 30 carry over, and subtract 5, become 25. But since it's a burst activity, you have to wait because they are looking for a small number. So I have to go to the next level and look at E and F and continue to carry over and see what will be the late start. And so you can compare between 25 and 10. So here, if you do that, 85 subtract minus 50 becomes 35, 85 minus 15 becomes 70. Look for a small number that becomes 35 minus 25, 10, 10, 25, which is smallest, the 10, and 10 minus 10 become zeros. So now you have early start, early finish. They'll give you better pictures. But one thing you don't know is the select time. And select time, as I explained to you, would be the subtraction of E early start from the late start. If the number is 0, meaning there's no select time. So do that, 85 minus 85, 0, 50 minus 35, 15, 35, 30 minus 15, 15. And now look, you have activity A, C, E, and H. The dotted line meaning the critical path. So when you were asked about critical path, the critical path would become activity A, C, E, and H. So those are the 4 activities as a good project manager you want to focus on without delaying any of those work with unstructured tasks on the critical path. As for other, you know how many days you can wait for each of them. And that way you will constantly managing your project without having any anxiety. You'll become very, very successful project managers. I hope now you learn how to compute and develop your project network diagram and calculate the path. Thank you very much for your listening.